welcome to Yet to Know AI. In the last video, we saw what are the types of artificial intelligence and what is Turing test in artificial intelligence. In this video, we'll see what are all the key components of artificial intelligence. When we say key components, it defines the main objectives or the main qualities that an AI model should attain. The first quality is learning. When it comes to learning, it will be a trial and error process. What is a trial and error process? Say for example, I'm training a dog to sit. If I tell the word sit, it should sit. While the first few days of training the dog, I'll provide a treat or a biscuit to every correct responses of it. Say for example, if I say the dog to sit, if it sits, I will give it a biscuit. If it doesn't, then I won't provide any rewards. If I'm not providing any rewards, the dog will understand that it is making a mistake. If I'm providing it a reward, then it will get trained to the particular word. If I say sit, then it will sit. So, the simplest way of learning is by trial and error. The second key component is reasoning. What is meant by reasoning? Say, for example, if I'm asking a person how a cat looks like, he is showing the picture of a cat. If I'm asking, why are you showing the picture of this animal? How do you say that this is a cat? Then he will try to support his result. He will try to find a reason to convince me. So that is called reasoning. If I'm providing a solution, then it must be appropriate. To tell that it is appropriate, I'll try to draw inferences upon the results that I gave. So that is called reasoning. Inferences are classified into two types. They are deduction and induction. When it comes to deduction, we will move on from a general statement to a particular statement. We can take the same example. If I am telling a person, Alice is a cat, can you tell me whether it has an ear? The person replies, yes. Why so? I haven't shown any picture of cat. I just told that Alice is a cat and asked him whether Alice has ears or not. He will reply yes. If I ask him to show any inference or provide any reasoning for his conclusion, he will say, in general, cats have ears. So, Alice, as he is a cat, he will also have ears. So, that is called deduction. From a general approach, if we are reasoning to a particular approach, then it is called deduction. It is already in a proof that the consequences are because of this statement. It is the traditional view that moves on from a general to a particular statement. The next is inductive inference. When it comes to inductive inference, we will try to reason from a part to a whole, that is, from specific to a general. Say, for example, I'm getting stomachache often. When I try to find the reason or the root cause of stomachache, every time when I get stomach ache, I might have eaten a spicy food. So I'm getting into a conclusion that if I eat spicy food, I'll get stomachache. I'm moving on from a specific to a generic approach. The next key component is problem solving. What is a problem solving? We have to reach a particular goal. For that, we will try to figure out a possible action or approach in order to reach some predefined goals or solution. When a system does that, then it is called a problem solving system. It is divided based on purposes. When the purpose is to solve a special a special problem, like say for example, I have to take attendance without human intervention, then what will I do? I'll place a system that scans each and every face of the students and it will automatically enter that the student is present. So we are tailoring or designing a system for a specific problem so that it can't be used to any other problems. That is, we are narrowing the solution. So that kind of problem solving is called special purpose. As told earlier, it is a tailor made for a particular problem and often exploits very specific features the solution in which the problem is embedded. So those features of the solution will be specific to a particular situation and that cannot be used for a wide range of applications. So that is called a special purpose problem solving. The next is general purpose. That is something opposite to special purpose. So, in general purpose, that solution can be applied to a wide range of problems. The next key component is perception. What is meant by perception? Perception is scanning the environment, that is, knowing the environment. That can be done by our sensory organs for a human being. Perception, in the sense, if we are looking at our environment, we will first see the sceneries or the person standing somewhere. We will try to scan the environment. The perception, when it is real, that is for a human, and it is artificial for an artificial intelligence embedded system. This artificial perception is advanced to enable optical sensors to identify individuals. Say, for example, in an autonomous vehicle, to drive without any human intervention, it will first look at the environment. It will look at the road. If there is no other vehicles, then it will increase its speed. If there is any vehicle in front of it, it will try to reduce the speed according to the distance between the vehicle in front of it. And robots roam through the buildings collecting empty soda cans are some of the examples of artificial perception. The next is language. Language is one form by which we communicate with the other person. Human environment is incomplete without language. Not only the usual languages, even sign language and braille can also be trained to an AI system. So these are the key components of artificial intelligence. And I hope up to this, the theoretical contents about artificial intelligence has come to a conclusion. From the next class, we will try to learn what are the main things that we have to learn when it comes to artificial intelligence implementation using Python or other programming languages. Thank you. I hope you find this video useful. Happy coding.